Can you see it?
Okay, I can do that. You are holding up a cell phone. Is there anything else I can help you with?
Yeah, that's pretty good. In this video, we're going to start a journey of building up some key solutions needed to implement speech-driven AI for robotics. It's taken me well over a month to make just this part of the video. To be more accurate, I've recorded it about 4 times. The reason why I have to keep doing it is because the AI space in particular keeps changing so fast, it's not funny. So instead of going through all the history and the reasoning behind this, let's just get on with it, shall we? OpenAI has a real-time API that enables voice prompting a model. But so does Google with the Gemini Flash 2.0 multimodal model variant. OpenAI's API access costs money, but Google is free. The crazy thing here is there are a whole heap of other technical reasons why Gemini Flash 2.0 is better than OpenAI's real-time API. But since Google's PR team appears to be taking a break, no one really knows about it. So we're going to be using Google's Gemini Flash 2.0 multimodal variant. To get an understanding of how all of this is going to work, let's take a look at a high-level architecture. Clearly, Google Gemini is a cloud service, but little birdies tell me a local variant may be available soon enough. We need to write a simple server to communicate in real time with Gemini. So we're going to create a WebSocket-based Python app to do that. The Gemini SDK is designed to be running on a server, not a client. So this solution also deals with our API key supply and such to Gemini's servers. Next, we need a client application, so we can stream some audio as well as a webcam for live video feed straight into the model. Now, just for laughs, we'll also ask for a response from the model using its speech output. All right, simple enough. So let's take a look at the Python server first and then the client after that. Okay, so having a quick look through the server code, it's pretty simple. And as always, we have that sort of disclaimer that this isn't production code, it's not meant to be. It's just really simple code to hopefully show you how this works. All right, so our Python, this is our Python server. It's going to connect directly to Google using their SDK. You can see we just have to set it up, passing in this Google API key, and we put it in here. It's a string. Now, they've changed it a couple of times how to do this, but just do a Google search and look for Google API key, and it's free of charge, easy to get. As soon as you grab it, then stick it in here. We have to, of course, at the time of recording this video, specify the Flash experimental model, and then we just have to set up some of the configuration in the client with that as well. Now, as far as this goes, nice and simple, where we start down the bottom. Obviously, it's a asynchronous system that's running here, because the very first thing we have to do is actually set up our local WebSocket server so our HTML, our index page, can send audio to it. So that's what we're doing here. We're just setting up a very simple local WebSocket server running and listening on this port, of course. And then everything else continues on from there. Now, as soon as we get some data coming into our WebSocket handler, right? So our client data is coming in here. You can see that we are setting up this configuration, and it's just stupidly simple to get this underway. Of course, you can add lots more properties and variables and parameters and stuff like that in here, including tools and all of those sorts of things. But to get this underway, you literally don't need anything more than this. You can see that we're using this object here, which is coming from the Google SDK, the Gemini SDK, sorry, and we're providing our model as well as our config into it, and it's running as a session, okay? So first thing is, obviously, we're going to send some information to Gemini, right? You can see we've got 2 functions in here, or 2 methods: receive from Gemini and send to Gemini, okay? So let's just take a quick look through here. I'm not going to go through line by line, but you can see that in this server, we are sending or forwarding two pieces or two different types of data. One is the audio data that we are sending from the microphone, which is audio PCM type data. And the second one is image or JPEG type data, which is images coming from the webcam. Okay, you can see that I've had to comment stuff out. They keep changing these versions very, very quickly. And so I think even from here to the last code I wrote is about 5 or 6 different version changes within a couple of weeks because they were going to release this code. Anyway, so thinking about it here, we're going through the data. We've got our audio data coming in and we're just squirting it with the session. We're sending it to Google, either this type of data, audio data, or we're sending input data to it, right? Nice and simple. And then obviously information comes back from Gemini and we need to figure out how to handle that. There is a couple of different types of data that we are getting back from them. We're either getting back text or we're getting back audio. The way we specify what the response type is inside the configuration. And we set that up in the index page as the first starting message, and we specify either text or audio. We'll cover that in a little minute. Now, I don't want to go into too much detail here because it's sort of outside the scope of this type of video, but dealing with the audio coming back is a little bit more complex than the text. I mean, text is really simple, right? It just comes back. And so you can see here, we take our client WebSocket, our index page, and we send the text directly to it. Now, in the case of audio, we've got to do quite a bit more sort of work, right? The type of audio data coming back has also changed. I don't know. I've put issues on their GitHub servers and they don't seem to think that there's any issues with this, but it does make it hard to work with if they keep changing the audio format. But literally, this is how I got it to work, that I take back this inline audio data, which is their model speaking, and encode it to a 64-bit encoding, and then I send that over to the client. Now, we'll go through this in the client in a little bit, but I wanted to keep the server nice and clean. So it's just taking data in, figuring out what it is, and then squirting it, right? It's sending it over to the client, right? So let's go and take a look at the client, the index.html page that connects into this. Okay, so looking at the index or our client page, it's very, very simple. Again, not production, right? Just some crusty code put up here. We just have very simple styling to get us a very basic, visualization happening in terms of our webcam and sending our audio in. In fact, I think I used ChatGPT for most of this just to really quickly knock something up, right, as a demo. So this is just layout and style, right? We're obviously going to see a microphone button that we click on and things like that. So we've got some function handlers and things like that for those features. The real key parts to see here is, as a JavaScript, we are connecting into our local host, our web server, which our WebSocket server, which is of course our Python server that we have up and running. You can see that we are creating a number of these elements, a video element on a canvas element and things like that. So we can see our webcam, we can see the images are coming back, and we're creating the start and the stop button effectively so we can speak to the model. So there's a heap of setup here, but nothing that's really that complex. In fact, when we get down into it, and you can see here, this is how we sort of set up and start our webcam. I'm not going to go through this in detail, but this is how we capture webcam images and send them to the model. You can see as the window.addEvent listener load is called, so when the web page itself loads up, the index page, it starts the web camera up straight away and starts capturing images, okay, every 3,000 milliseconds. Okay, so when we connect, we're connecting into the WebSocket, into our WebSocket service, so pretty simple there. The only thing we've got to deal with is when data comes back to us, okay, when we receive messages. Here is that initial message I was talking about, where we just specify here the response modalities parameter, and we can either have text, so you write it uppercase text, or audio. And just, as I was saying for laughs, we're going to listen to the model speak back out. Now, obviously, this adds a little bit of latency in the response from the model because it's audio data. If you switch this over to the text, you can see extremely fast that the model is responding. But let's do it with audio, and it's still pretty impressive. Okay, so we're sending that sort of startup message to our server to say we're ready to go. Now, this is all about sending and receiving voices and voice messages and stuff like that, right? Now you can see that we have to create a payload to squirt over to our WebSocket server, and we have to decide whether we are sending audio data or image data. And so that's what these functions are doing. They're handling sending a message. The received message comes in, and remember, when it's audio, we really have to start working on trying to figure out how to decode the audio data that has come back over. Again, I'm not going to go into it too deeply. We've got special functions here that are taking the audio data and converting it. One of the things we need to do, this is this external JavaScript that's up here in this class with this class PCM processor. It enables us to process the audio data into the right format in order to play it back out inside of our index HTML page. We're converting, audio data, and it gets way too complex and way too outside the scope of this video, but it's all here in the code, and it's pretty much just simple functions around starting and stopping the audio and displaying messages if we've got text and stuff like that. The response is a structure as the data is being processed. Okay. All right, so let's get this up and running. And for that to happen, I'm just going to go back into my Python file. I'm going to change out and add my API key in here. I'm going to run a very simple Python server so I can view this index HTML page as a served HTML page. Let me get that all set up, and we'll come back to the web page. Just so you know, I can't do any screen recording on the big screen. I can only do it on the little one. So I'm going to set the camera up in this corner to look over my shoulder so you can hear me talking using this microphone, and you can see the screen responses all in real time. There's no magic editing going on here. And you'll also hear the response from the room speaker. So it'll sound a bit rubbish, but this is so you can see and hear, I guess, for yourself just how fast this service really is. Okay, so here's our client, and what you'll notice is obviously the webcam, which is in front of the computer that's showing the screen. I've had to turn all these lights off, and I've even had to change the color of my shirt. What's really important is that you get very crisp, clear images going into the model for it to be able to recognize certain things. Anyway, I've got the videos, the camera's rolling in different angles and stuff like that. Let's just see if this will work, and we'll go from there, yeah? Okay, let's connect in, and now I have to turn this on, and let's see how we go. Hey there, can you hear me nice and clearly?
Yes, I can hear you nice and clearly. Is there anything else I can help you with?
Yeah, I'm wondering if you can take a look at the webcam and tell me what I'm holding up. Can you see it?
Okay, I can do that. You are holding up a cell phone. Is there anything else I can help you with?
Yeah, that's pretty good. It took you a little bit to figure it out, though. But what about this pair? Can you tell me what these are?
Yes, I can see the cell phone that you were holding. Is there anything else I can help you with?
Yeah, what else am I holding up now?
Certainly. You're now holding a pair of yellow-handled wire cutters. Is there anything else I can describe?
Ah, very good. All right, thanks very much. Pretty amazing capabilities for relatively simple code being pushed in through an API to a server. Now, working inside of web apps with things like a microphone connected into your computer, makes everything pretty simple, right? Because the complexity has been taken away by those underlying libraries inside of the web browser apps in particular. Now, if we want to take this and put it into something like a robot or a device that we want to talk to and command, then we're going to have to make our own microphone, and not just any old microphone. We can't just save the audio to disk and then send it off somewhere else to process. We need a true, proper streaming audio microphone. Now, that's what we're going to do in the next video. We're going to extend this solution that we've been working on, and we're going to build an AI streaming microphone to get the next step along the way of putting together real-time speech-driven AI in robotics. We're going to give away one of those microphones as well, just as I mentioned in the last video. So if you'd like to get notified of that video, be sure to subscribe. Now, if you like the source code or you want to get the source code and design files and things like that, I'm making available to supporters and friends over on Patreon. Patreon membership is about $3 a month, about the price of a cup of coffee. And that sort of support really helps me enormously. I mean, the channel's not monetized in any other way. There's no advertising revenue or anything like that coming in. So any support would be really, really appreciated. I want to send out a special thank you to the people that have already signed up on Patreon to help me out. It's amazing. It just blows my mind when people support what I'm doing. All right, you also know what to do in terms of finding the friends of the channel. Their details are down in the description below, along with Patreon, and all the other information about this video are going to be found down there. If you've liked this video, please give it a thumbs up. That's not just an indication to me, but it actually is the primary indication to YouTube that they should send this video to other people. If you've never interacted in a comment before or introduced yourself, by all means, jump into the comments, just say hello. Introduce yourself, it'd be great. That's the thing that actually drives me, is the interaction with people on this YouTube channel. So you've made it this far. I thank you. I can't thank you enough. I am the Old Man Maker, and I will see you in the next one.